So remember we talked about, okay, we have all these numbers. We have to make them mean something. They don't mean anything unless we put a unit behind it. So let's talk about the different units we're going to put behind them. We talked about the international system of units. And remember we called them SI units, and that's so that scientists around the world can be on the same unit system. It's loosely based off of the metric system. The first unit of measurement we talked about was length. And length just kind of measures a distance. The SI unit for length was a meter. And we abbreviate it with a lowercase m. I gave you guys some conversions that you don't necessarily have to memorize, but they come in handy when you're doing the homework problems when it comes to length. So we talked about the kilometer, 1 kilometer equaling 1,000 meters. We talked about 1 kilometer also equaling 0.6214 miles. 1 foot was 30.48 centimeters. We also need to know 1 foot is 12 inches. And then 1 inch is 2.54 centimeters. So the ones that are going to come up the most in this class are going to be this one right here, this one right here, and probably 1 inch, 1 foot equaling 12 inches. So you'll see those three a lot when it comes to length. We talked about how to do conversions. We use what is known as dimensional analysis, and it's just setting up fractions, multiplying fractions by each other so that we can cancel out our units. And I'm just reminding you guys that if we can do conversions, I'm going to spend a lot of time today working on conversions, mainly because it's such an essential part of this class. And if we can do conversions, guys, everything else in the class will be a lot simpler. Even when we get down to the chemistry, we set up the conversion in our chemical equation and everything will work out perfectly. So just a reminder on the dimensional analysis. Dimensional analysis is just a way to do conversions. So if I give you, for example, I want to convert 55, let's just even say feet to inches. All dimensional analysis tells us to do is take our given number, which is our 55 feet, and multiply it by a fraction, and that fraction is just going to be what the conversion is from feet to inches. So the way I'm going to say it is that the unit that I start off with, which is feet, I'm going to make sure I put that unit in the bottom, so that way I have one at the top, one at the bottom. They're going to cancel each other out. And the unit that I'm looking for, that's always going to go at the top. And then I just simply write in what the conversion is. The conversion says 1 foot equals 12 inches. So I'm going to say 1 foot. I'm going to put the 1 in front of foot and the 12 in front of inches. So now it's like a big old fraction. I have feet at the top, feet at the bottom. They're going to cancel each other out. And then all I have to do is put this in my calculator and say 55, open parentheses, 12 over 1, close parentheses.
Next.
Yep, so now when we talk about, and I'm going to put it in just like I wrote it on my paper, 12 divided by 1. Now when we talk about sig figs, when we do conversions, remember whatever number of sig figs you start off with, because this is multiplication and these are exact numbers. Remember, most of these are exact numbers. Exact numbers. And remember, exact numbers says that it has an unlimited amount of sig figs, so you do not count the sig figs. So there are exactly 12 inches and 1 foot, so we don't even count the sig figs in this conversion. We're going to go off the sig figs we start with. We started with 2 sig figs, so our answer should have 2 sig figs. And it looks like it does 1, 2. We don't put a decimal behind this 0 because if we do, it'll make it more than 2. So 660 is one way to represent this, or we can say 6.6 times 10 to the power of 2. And this is going to be inches. Either one works. I'll accept either one of these answers. All right, you guys remember this from last week?
Yes.
Yes.
All right, so we're going to do some more problems. I then went on to talk about the dimensional analysis. So not dimensional analysis, prefix multipliers. Prefix multiplier, yep.
Sorry, I have a question.
Mhm.
Can in the calculator, I noticed that you put in 55 open parentheses 12 divided by 1 close parentheses.
Mhm.
Can I just go ahead and do the 55 times 12?
Yeah, if you put it in there, you should have gotten the same answer.
I did. I was just wondering why you were doing that. Like, is there?
I want to set up a habit. Sometimes the 1 is
Okay.
at the top, sometimes the 12 is at the bottom. But I mean, I think most of you guys can see this is just 55 times 12. I want to set the habit up because we're going to have multiple steps a lot of the times, and I just like to write it on the paper the same way I put it in my calculator.
I see. Okay.
So remember we talked about prefix multipliers last week. Prefix multipliers are just what they sound like. They are a prefix that can be multiplied by any of the base units. So our base unit for length is a meter. So that means I can have a terameter, a gigameter, a megameter, a kilometer, a decimeter, centimeter, a millimeter, micro, nano, pico, and femto. One of each one of these prefix multipliers is equal to this conversion. It's equal to either this number or this number. I'm going to write it in the exponent form just because that's just less zeros to write it in. But that's how we read this chart. We're going to say one of each one of these equals this. So that's why I stick these ones out in front. So I'm saying 1 megameter equals 10 to the power of 6 meters. 1 kilometer equals 10 to the power of 3 meters. Okay, so the only unit that we've talked about of measurement is length. Let's just do one more example. And let's use an example with a prefix multiplier. So let's say, for instance, I have, let's say 55 again, 55, but this time I have 55 kilometers, and I want to know how many, let's say, nanometers that is. All right, so what I suggest you guys do is become familiar with these prefix multipliers, because if you're spending a lot of time going back and forth on a worksheet or trying to Google what the prefix multiplier means, it's going to take up a lot of time when you're answering questions on quizzes and tests. So I would memorize these prefix multipliers. So when I see kilo, this K, the K stands for 10 to the power of 3. Or the N means that I'm talking about 10 to the negative 9. So the way this sets up is I'm going from kilometer to nanometer. So kilometer, like I said, 1 kilometer equals 10 to the power of 3. 1 nanometer equals 10 to the negative 9. So when I set this up, I don't have a conversion that goes straight from kilometers to nanometers. I didn't give you one of those conversions up here. What I gave you is conversions from a prefix to the base unit. And we know that the base unit is a meter because that's the second letter. So my suggestion is for you to go to a meter first and then go from a meter to a nanometer. All right, so let's set this up and do this one together, where we're going to say 55 kilometers is what I'm starting with. And then I want to convert it to meters and then to nanometers. So you guys just read out what I should write in first, or tell me. So in the first parentheses, what am I going to put at the bottom? What unit?
Meters.
Kilometer.
Kilometers.
No en kilometer.
Kilometers.
We're gonna do kilometers because remember, I want the kilometers to cancel out. Whatever unit I start with, it's always gonna go in the denominator in the first parentheses, okay? So then at the top, Lizette, what do you think I should put at the top?
Meters.
There we go. Perfect. All right, so then the next one, what unit goes here at the bottom now?
Meters.
Meters, perfect.
Meter.
And then what unit goes at the top?
Nanometer.
You guys are great. Okay, now the tough part, let's see if we remember. Where do I put my 1? In the first parentheses. Where am I gonna put my
At the
1?
bottom.
The bottom. Yeah.
At the bottom. Where am I gonna put my 1 here?
Top.
At the top. So it's not always gonna be at the bottom. It's not always gonna be at the top. Sometimes it switches. And it depends on where you put your prefix. So remember, I said one of each one of these prefixes equals this exponent. So 1 kilometer equals 10 to the power 3, or 1,000. 1 nanometer equals 10 to the negative 9.
Negative 9.
All right. So the way I put this in my calculator, remember, I'm going to use the EE button. I'm just going to write out how I'm going to put it in my calculator. I'm going to say 55, open parentheses, E3 over 1, close parentheses, open parentheses, 1 divided by E negative 9, close parentheses. So that's how I'm going to put it in my calculator. So I'm going to say, let me type that in. 55, open parentheses. Remember, I'm going to use the EE button. Some of you guys might have to hit the second to get the EE button. So I'm going to say E3 divided by 1, close parentheses, open parentheses, E. And remember that the negative 9, the negative button is this one down here. Sorry, I need to say 1 divided by negative 9. 1 divided by E negative 9, like this. And then just press enter.
5.5 times, yeah.
5.5 meters. Oh,
Perfect. So
Times,
let's make sure we're all getting this in our calculator so that way we make sure we're typing in correctly. And that is your answer with the correct sig fig, because remember I started with 2 sig figs, so my answer needs to have 2 sig figs. I'm going to say 5.5, and then we can say E. I'll accept E13. This is how I want you to write it in. If you have to write it in scientific notation on the homework, this is how I want you to write it, E13. Or you could say 5, not on the homework, but in real life, 5.5 times 10 to the 13. These are saying the same thing. And this is going to be nanometers is our unit. And this is our answer. Any questions on how I set this up? I can't, let me read the chat. Give me a second, guys, to read the chat. So 55E12 is the same thing. It's 5.5 times E to the 13, I mean, E13. I'm not sure why your calculator didn't put it in scientific notation for you, but that's the same answer, but you would have to correctly put it in scientific notation, which would be 5.5 times 10 to the 13. All right. Let's keep going. Let's go to, if I don't have any questions, that's great, guys. That means we understand it and we can keep going. So we talked about length. That's the first type of units we talked about. Let's talk about mass right quickly. Let's see, what time is it? All right, yeah, let me talk about the other types of measurement. We could take a break and then I'll come back and I have a worksheet where we have to do a bunch of these problems. I lied, I gotta show you how to do a bunch of these problems. So give me like 15 minutes and I can go through this pretty quickly. So the second type of measurement is mass. All right, the SI unit for mass is a kilogram, not a gram, but a kilogram. Put a star by that, a question on a test. What's the SI unit for mass? A lot of you guys think it's a gram because it makes sense that it would be a gram, but it's actually a kilogram. We abbreviate it KG. Some quick conversions. 1 kilogram is going to equal 1,000 grams, or we could say 10 to the power 3 grams. 1 kilogram is also going to equal 2.205 pounds. That's what we use here in the US. We use pounds. Pounds are abbreviated LB. Mass is just a measure of pretty much how much stuff you have in you, how much matter you're composed of. And so when we think about mass versus weight, you know, we measure our weight here in the US. Our weight depends on gravity. So, you know, if you leave this planet ever, I don't know if we ever will, but if we leave this planet, our weight would be something different, but no matter where we go in the universe, our mass is going to be the same, because it's just a measurement of all the matter, all the material that's made up, that our body is made up of. All right. Another helpful conversion that comes up, I think, on the homework. So 1 pound is equal to 453.59 grams. Grams is abbreviated with a G. And then 1 ounce, which is OZ, is equal to 28.35 grams.
Do we need to memorize these as well?
No, you don't have to memorize them, because, you know, you're going to have, I can't see what you guys are looking at. If we were face to face, yes, I would say memorize. Maybe, you know, you definitely have to know this, and that's all I would have you memorize of this section. But what is important that you guys understand is that we can use the prefix multiplier. Just like we have a kilometer, we can have a kilogram. So just like we have a centimeter, we can have a centigram. So basically, the base unit for mass is still a gram, but now instead of writing 1 terameter, we can write 1 teragram. 1 teragram is equal to the same thing, 10 to the power 12, but this time it's grams. And, you know, like I said, mass is just a measure of material. It's like, you know, when you have a balance, you measure the mass of something on a balance. 1 megagram, if we put gram as the base unit, it's still going to equal 10 to the power 6 grams. 1 microgram, it's still going to equal, sorry, this was 10 to the positive 6, 10 to the negative 6 grams. So we can have these same prefix multipliers go with mass as well. And yeah, so that's for mass. Let's keep going with time. Time is another type of unit that we're going to use a lot. In time, we know time. We talk about the second. The second is the SI unit for time. It's abbreviated with an S, a lowercase s. Most of us know this already, that 1 hour is equal to 60 minutes. And we're going to abbreviate minutes, MIN. 1 minute is equal to 60 seconds. And 1 day has 24 hours in it. Just like with mass and length, you can have those prefix multipliers in front of all different types of time. So for instance, we can have a kilosecond, we can have a microsecond, a nanosecond, a megasecond, a gigasecond, all those different prefixes in front of the second as well. And then the last type of measurement I want to talk about is volume. All right, volume is what is known as a derived unit. And when we talk about volume, when I say a derived unit, it means, you guys remember the equation for volume in math? Like, let's say I have the volume of a square or a cube. Matter of fact, a cube is a better example. What's the volume, the equation for a volume in math?
A length times width times height.
Yeah, perfect. So we're saying length times width times height. And these are all measurements of distance. So when we say distance, the SI unit for distance is, length is meter times meter times meter. So the SI unit for volume is going to be meter cubed. So that's why we say it's a derived unit. It comes from other units. So meters cubed, the one main one that's going to come up a lot in this class, although meters cubed is the SI unit for volume, you're going to see liters a lot in milliliters when we talk about volume. So let me give you some examples. So for instance, 1 centimeter cubed is the same thing as saying 1 milliliter. So let me just tell you what a liter is. So 1 liter, and we abbreviate liter with a capital L. 1 liter equals 1,000 milliliters. Or we can say that's the same thing as saying 1 liter is equal to 1,000 cubic centimeters. One liter is also equal to 1.57 quarts, and that's abbreviated QT. And then 1 US gallon, which is abbreviated with a gal like this, is equal to 3.785 liters. Like I said, you don't have to memorize these. What I need you to have memorized are the prefix multipliers, meaning, so if I have a liter, that's like saying I have 1 milliliter is going to give me 10 to the third liters. I should have written it that way. Let's do that so I don't confuse you guys too much. I'm going to say 1 milliliter is equal to 1,000 10 to the negative 3 liters. How about that?
Can you raise up your paper one bit, Professor, please?
Yep, is that better?
Yeah, thank you.
Could you move it to the right a little? Thank you.
So just know that anytime you have a unit of length, which is a meter, and you raise it to the power of 3, it's going to give you volume. All right. So I just want to do a bunch of problems that are going to show us how to do conversions. Let's see. Yeah, give me another, give me to 10 o'clock. I'm going to try to do this quickly, and then we'll take a break. So right now I want to do a bunch of problems. It's just going to give us some conversions. All right, let's start off saying, let's do some examples. All right, my first example, let's say I have 4.0 and I have a microgram. So micro is the unit that looks like this funny looking M or this funny looking U. That's a micro. So microgram, and I want to convert it to picograms. All right, so I'm just recapping, doing another one like we just did. This is mass because I know that G stands for gram. Grams is the unit of mass. So I'm going to say, okay, I know how to go from microgram to gram, and then I know how to go from gram to picogram just by looking at the prefix multipliers. So let's work through this one really quickly. So 4 micrograms, 4.0 micrograms. Can you guys tell me how many sig figs I should have in my answer?
1 and 2.
2. We see 2? 1, 2. This 0 is significant because there's a decimal there. All right, so if I set up, what's going to go at the bottom in my first parentheses?
Micrograms.
Micrograms. What's going to go at the top?
Grams.
Grams. Perfect. The next one, what's going to go at the bottom?
Grams.
Grams.
What's going to go at the top?
Picograms.
Picograms. Great. Where are my ones going to go? Right. In this one, where's my 1 going to go?
At the bottom.
1 at the
Where's
bottom.
my 1 going to go here?
At the top.
At the top.
So all we have to do is look at our prefix multiplier sheet and say, okay, what do I do now? Micro, which is this funny looking M or a funny looking U, stands for
6.
10 to the minus
6.
Negative.
10 to the minus 6. Pico stands for 10 to the minus 12. I put this in my calculator. It's going to look like 4.0, open parentheses. I'm going to say E, -6, divided by 1, close parentheses, open parentheses. 1 divided by E, -12, close parentheses. You guys told me I should have 2 sig figs, right?
Yes.
So let's express this answer with 2 sig figs.
4.0
Mm-hmm. Anything else?
Times 10 to the 6.
1
And 6, yeah.
4.0 times 10 to the 6. So 4.0 E6, or 4.0 times 10 to the power of 6, which in this case, we're talking about grams. So I'm going to say grams. So remember, if it didn't give it to you in scientific notation, you can always change the mode, or you just count the zeros. 1, 2, 3, 4,
6.
5, 6. We see that we have to move the decimal over 6 spaces. All right. So let's say I have the same conversion. Well, at least the same number. Let's say the same number, but this time I want to convert it. Let's say, how do I want to convert it? I want to
I'm sorry, I have a question.
Yeah.
The other one says grams. Should it be picograms or is it just grams?
Thank you. It should be picograms. Sorry. The answer should be picograms because I'm getting rid of micrograms, I'm getting rid of grams, and I'm left with just picograms. That's what I'm looking for. Thank you, whoever called me out on that. All right, so let's say I have a unit raised to a power, like I would with volume. Let's say I have 4.0, and let's say micrometers cubed, and I want to convert it to picometers cubed. So I'm still using micro and pico again, just because it's easy right there in front of us. So remember, any unit raised to a power of 3, any meter that's going to be raised to a power of 3 is going to be a volume. And this comes up a lot when you have units raised to a power of 3. Now, when I have a unit raised to any power, I can set it up similarly. So I'm going to say 4.0 once again. I'm starting off with micrometers cubed. The conversion, I still want micrometers down here at the bottom. I want meters at the top. Do it again. I want meters down here, picometers. You guys following me so far?
Yes.
All right, I'm going to put my 1 in front of the prefix. Micro stands for 10 to the minus 6. Pico stands for 10 to the minus 12. But this only gives me picometers, and I need picometers cubed. So to get a unit raised to a power, I have to raise everything in parentheses to a power as well, to that same power. So I can't cancel this out just yet because this says micrometers cubed, this says micrometers. They don't cancel each other out. It'll just change this to micrometers squared. I want to cancel them all out, so I have to raise everything in parentheses to the power of 3. Same thing here, raise everything in the parentheses to the power of 3. So now I'm saying 1 is raised to the power of 3, micrometers is raised to the power of 3, 10 to the minus 6 is raised to the power of 3, meters is raised to the power of 3. And now they can cancel each other out. So although it's similar, because I have micro and pico, the difference is this unit raised to a power. So let me write that here. This is units raised to a power. All right, so units raised to a power, you just have to make sure you put everything in parentheses, you raise it to that power as well. So the way I put this in my calculator is I'm gonna say 4.0, open parentheses. I'm still gonna say, look, notice I'm not putting cubed by my 4.0. This is just the unit that's given to me, which is a unit of volume. You do not cube the 4.0. So I'm gonna say E -6 divided by 1. Once again, close parentheses, but this time I have to cube this parentheses. So to cube that parentheses, on this calculator, I can simply just press this X to the power of whatever. You can pick what your power is. So I'm gonna pick that my power is 3. On this calculator, I think when you write it in, you say let me turn it on. 4.0, open parentheses, and what is it again? E -6 divided by 1, and we're gonna use this caret up button. So I can say, now raise that to the power of 3. If you have a TI-84, one of the graphing calculators, I think if you just go to mode, there's an option for you to, sorry, not mode, maybe it's math. There's an option for you to just raise whatever you have to the power of 3. But this is the calculator that I'm going to use most of the time. You just hit this X to whatever and you type in what power you want. And on this calculator, you use this caret up and then you type in what power you want. So raise it to the power of 3, open parentheses again. Sorry, let me go down. All right. Open parentheses, 1 divided by E -12, close parentheses, and I'm going to raise it to the power of 3 as well. So you have to raise the parentheses, and only your parentheses, guys. Let's put a star next to that saying only raise the parentheses. This is what you should get in your answer, but we need how many sig figs in our answer, guys?
2.
Two.
So how do I express this with 2 sig figs?
4.0.
Yep.
E18.
Yep, so I would say 4.0 E18 or 4.0 times 10 to the power of 18, and that's going to be picometers cubed. Picometers cubed. So I'm going to put a star right here that says only raise the parentheses to the power, or exponent is what I'm saying. Meaning, do not say 4.0 cubed. You're only going to do it with the parentheses. It's already cubed in the unit. Okay? Any questions before I keep going? I just got one more example to show you, and then I'm going to give you a break. All right, let me read the chat right quickly, just in case I'm missing something. All right, got it. And then the last one is if we have a unit that is in a fraction. Sometimes we have units in a fraction. So for instance, sometimes we have a unit that looks like grams per liter or milligrams per liter. Let's say we have 4.0 once again, and I'm just going to use the micro and pico again. So I'm going to say we have micro grams per liter, and I want to convert it to grams per milliliter. So these are units and a fraction. All right, guys, just listen to what I'm saying before you write down. We are saying micro. I should have said pico, but either way. Yeah, let's change this to picoliters so we know. No, it's okay. All right, so what we're gonna do first is we know how to go from micrograms to grams, right? We've done that multiple times, just going from a prefix to a base unit. And we know how to go from liters to milliliters. So I'm just going to do one at a time. I'm just going to ignore the denominator and go from micrograms to grams. And then I'm going to ignore the numerator and go from liters to milliliters. So if I ignore the denominator, I know how to set this up. It says 4.0 micrograms. I'm going to take it to grams first. So the first step is going to say micrograms at the bottom, grams at the top. 1 microgram equals 10 to the minus 6. You guys follow me so far?
Yes.
All right, so we know how to do that. So we're done at the top. We're at grams already, so we're happy. Now I'm going to ignore the numerator and I'm going to convert liters to milliliters. So now I can plug in, I'm going to write it in a different color so it's clear. So now I'm going to plug in liters because that's what I started off with, microliters, and I'm going to convert my liters to milliliters. But the only difference in this step is that liters are at the bottom. So if I want to get rid of the liters, where should I put it in this parentheses, the bottom or the top?
The top.
At the top.
Exactly. I want to put it at the top so I can get rid of it. So that means I'm looking for milliliters. And now my liter is going to cancel out. 1 milliliter, we look at the table, 10 to the minus 3, if that's what 1 milliliter equals. So now micrograms cancels out, and I'm left with just grams at the top. Liters cancel out, I'm left with milliliters at the bottom. Do we see that? And that's all it is. We're trying to go from micrograms per liter to grams per milliliter. We have grams at the top, milliliters at the bottom. We can put this in our calculator. We're now going to say, same way we set it up, we still need 2 sig figs. 4.0, open parentheses, E negative 6, divided by 1, close parentheses, open parentheses, E negative 3, divided by 1, close parentheses, hit enter. This is what we get. We want to write it in scientific notation because I don't want to write all those zeros. So you guys help me write this in scientific notation.
Four.
4.0 times 10 to the negative 8.
4.0 times 10 to the negative 8. Let's move our decimal. 1, 2, 3, 4, 5, 6, 7, 8, and we got to move it one more to make it 9. So close. It's probably just because you're not in front of it, but yeah, we're going to make it 4.0 times 10 to the negative 9. And this is going to be units of grams per milliliter. And we can say 4.0 E negative 9 grams per milliliter. Same thing. All right. Sorry, I went over the break time. Let's go ahead and take a break. If I have a question, you guys stay and ask me your questions. But if not, we can go ahead and take a 15-minute break. So we want to come back at 10:25.
Okay.
And let me know if you guys have any questions. When we come back, we're going to do a worksheet. We're going to do that conversion worksheet. We're going to break out into breakout rooms and spend some time going through that. Let you guys have any questions. All right, here we go. So we just got to do it over and over again. I have another worksheet that I'll put up just for practice that looks similar to this one, and that looks similar to this worksheet is what I'm saying. And then you'll just have it for practice. All right, so that's the first step. We're going from meter squared to centimeter squared. The second step says we want to go from minutes to hours. So if I put minutes right here, I then want to go to hours. So what do you guys think I need to put at the top?
Minutes.
A minute.
Minutes, perfect. And what's going to go at the bottom?
Hours.
And then we can just plug in what the conversion says. 1 hour equals 60 minutes. And that's it. So then we put it in our calculator. If we put this in our calculator, you guys let me know what you get for an answer.
Do we have to square that parentheses as well?
No, we do not. We only want to square the
Oh, the meters, right?
meters to centimeters, because if we look at the question says we're going from meter squared to centimeter squared. So that's a good question, because a lot of times when I have set up a conversion like this, you guys will just square all the parentheses, and you don't have to. You have to look at what your unit is asking for.
Okay.
All right, so you guys let me know what you get. How many sig figs should I have in my answer?
2.
2.
2 sig figs, and let's see what we get.
9.3. Yeah, then-
Say it again, Johannes.
Oh, my answer is like 9,266.66. I got like this number.
Okay, but we need 2 sig figs, so let's round it to 2 sig figs.
9.3.
Did anyone else get that?
No.
I got 33.
No. I got
4
Yeah.
to the 6.
3.4.
4.4?
3.4.
3.
I got
3.4.
Would you be able to
3.36.
explain how to do it on the calculator?
Okay, let's pull out the calculator. All right, 5.6, open parentheses. 1 divided by E negative 2. Are you guys getting the E down? Are we having trouble with the E?
Yes.
Which calculator do you have? Do you have this calculator or
I have
this?
a T1 30XS multi-view.
Is it more like this? I'm not sure what one that
Yeah,
is.
it's a little simpler than that one.
Let's see. Let me go get out of here. Exit full screen. Can you show me what your calculator looks like in the meantime? And I'll just do it on this calculator, just for those of us who have this calculator. All right, so I'm still saying 5.6. Put it up to the screen. Do you have an E button? Did we talk about this already? Do you have an E button on your
I'm
calculator?
still having trouble with it. I'm putting second and oh, there we go. There we go. Sorry.
Okay, you got it?
Yeah, I got it.
All right, so 5.6, open parentheses. Can you guys see my screen?
Yeah.
5.6, open parentheses. I'm gonna say 1 divided by, and I have to press second to get to the E on this calculator, E -2. Close parentheses. There's a square button already. So I'm gonna hit the square button and then it gives me what I have in parentheses squared. Then I'm gonna say open parentheses, 60 divided by 1, close parentheses. Okay? And then hit enter. So Johannes, did you actually square 5.6?
Oh,
You just might have had a typo.
I think so.
All right, so if we take this and make it 2 sig figs, remember, we're gonna say 1, 2, look to the right and round up. So we need to change this 3 to a 4, and then we gotta make basically everything else 0. So if I write this in scientific notation, I heard some of us say it,
3.4 times 10 to the 6th.
it's 10 to the 6th, looks right to me. 10 to the 6th.
I have a question.
Mhm.
Okay, so you know how in one of the problems we put the whole right after the parentheses, after we did, so like in this case, we would do 1 divided by 10 to the -2. Why in the other problem we did 1 divided by 10 to the -2 and then we did the exponent? Why in this case we did 5.6 and then in parentheses we automatically put 1 and then exponent 2? I don't understand that.
Maybe is it one of these examples? Can you tell me which one you're talking about?
Yeah, it was. I don't know if I'm explaining it the way that like you'd understand it, but I think that in one of the problems, we automatically did the exponent like right after so like in this case, we did 5.6 and then in parentheses, we did 1 divided by 10 to the -2. And then I thought in the other problem, we did the square right after we did the parentheses. But in this case, you did it 1 and then squared and then divided by 10 to the,
I
right?
didn't. No, I didn't.
Okay. Maybe
So
I seen it wrong, sorry.
Yeah, so look, I did it the same way. 1 divided by 10 to the -2, close parentheses, square.
Okay, never mind. I seen it wrong then.
Okay, that's fine. All right, so that's fine if you guys ask me those questions too, just so it can clarify and make sense in your head. I don't want any confusion because sometimes that just happens. We're on video, I'm not in person, so you know, I'm flashing things on the screen real quickly. All right, so that was number 10. You guys feel like you can do number 15? How about we just spend a second and do number 15? You guys spend a second, write out number 15 and see if we all get the same answer. All right, let's see if we can talk through it, guys. All right, so we're gonna say we start with 120 milligrams per liter. And we are going to ignore the liter, right? We're gonna ignore this liter. So first thing we're trying to go to is milligrams to grams. We know how to do that. Milligrams to grams, what's that look like? You guys tell me what the setup looks like.
Milligrams on the bottom, and grams on the top.
Perfect. Where's my one go?
Down.
Bottom.
What's milli stand for?
Million or thousand, so 10 to the negative 3.
Perfect. Okay. Milligrams cancel out. I got grams. Now I have grams per liter, but I want grams per milliliter. So I'm going to ignore my milligrams and all that mass, and I'm just going to focus on my liters, which is the volume. And I'm going to say, where's my liters are going to go to cancel them out?
Oh,
At the top.
And what's going to happen at the bottom?
Milliliters.
Milliliter.
So then in this case, where's my one go?
Liter, 1 liter, or 10 to the negative
10 to the negative 3 again. So it's 1 milliliter, or I think you were trying to say 1 liter equals 1,000. Is that what you're going to say?
Yeah.
Okay, that works too. I'm just going to keep the same with the prefixes. But so what'd you guys get for an answer then?
1.2 times 10 to the negative 4th.
Times 10 to the negative 4? Can I get someone to second that?
Yes.
Yes.
10 to the negative 4, and my units are what, guys?
Grams per milliliter.
Grams per milliliter. All right. This makes me remember for the homework, when you're typing in your answers for the homework, you don't have to use units. You could just type in the number. You don't need to write the units in. So for instance, I wouldn't need to write in grams per milliliter. I would just have to write 1.2 E negative 4. All right. So how do we feel about these conversions, guys?
Not good.
Not
It's a
good?
little confusing.
Definitely we
It's a little
need
confusing.
practice.
Yeah, you need some more practice. So I have another worksheet. Let me see. Let me unhide it. Let's go on. If we go to Brightspace, where's my Brightspace? All right, let's see. We go back to content. We're doing lecture worksheets. We're back at chapter 2. Let's see. I have another worksheet, conversion worksheet, extra practice. Let's unhide that, make visible.
Professor, before you move on, I have a question. For the second part of the equation, the 10 to the negative 3 liter over the 1 over the milliliter, why wasn't it 1 over the 10 to the negative 3 again? Is it because you want the milliliters, that unit, to be on the bottom? Is that why? And you have to cancel out the liter on the other side?
So liters at the bottom, liters at the top. So you're saying why wasn't milliliters at the top and liters
Yeah,
at the
because
bottom?
I thought it would be 1 liter over 10 to the negative 3 milliliters. So that's
Well,
not correct.
We always put the 1 with the prefix. So the prefix was at the bottom here, so we put the 1 there. The prefix was at the bottom here, so we put the 1 there. The reason that the milliliters is at the bottom versus being at the top, because normally we're trying to cancel out top, bottom, but this time it started off at the bottom and we needed to get rid of it, so we put it at the top.
Okay, so the 1 goes with the prefix.
Always, yeah. And
Okay.
I mean, you can write it another way, but if you write it the other way, you've got to remember to change the sign, and that's hard for you guys to remember. Do you get what I'm saying? So I think it's easy just to remember the 1 goes with the prefix.
Sorry.
Yeah, that's gonna have to be better. Yeah, the prefix goes with the 1
If
because
you
I
have to
keep
take
confusing it.
Yeah, the prefix, just if it has 2 letters for the most part, like milliliters, megaliters, centimeters, you gotta just put the 1 where the 2 letters are. The only time that comes in confusion is like if you have hours and minutes and things like that. Those aren't prefix multipliers. Only when we're talking about the prefix multipliers, like what's on this sheet, the tera, giga, mega, kilo, all those things. Any of these, that's why I put the ones on this side. These are all one of these equals that many number, this number of any unit you're talking about.
Okay, that makes more sense.
Okay, all right. All right, so if we go back to Brightspace, guys, you should see another worksheet that says extra problems. Do you guys see that worksheet that says conversion worksheet, extra practice?
Yes.
All right, it's just more problems that you just work out and practice with. These are pretty much all the different types of conversions we're gonna, well, when it comes to prefix multipliers, we're gonna have to use the prefix. Basically everything we're learning in this chapter, we gotta use throughout the entire semester. So we're about to talk about density. We're gonna have to do conversions when we calculate the density. Even though we're given an equation, we're gonna have to do conversions with that. So like I said, the more and more we do this, the more and more it's going to become easy in your head. We're just going to add a parentheses to whatever we're trying to work out. All right. I know you guys are like, this is frustrating, but like I said, we do it so much that it's going to become a lot easier. Just give yourself a little bit of time. It takes some time for it to set in. All right.
Professor, before that, can you do like number 9, please?
Oh yeah, I see your question in the chat. Let's see, number 9 right quickly. All right, if I look at number 9, I want to do this one. I want to make this the last one, and I want to talk about density because I want to do the density lab on Wednesday. So 50 centimeters cubed. All right, talk me through it, guys. This is a unit raised to a power. What unit goes at the bottom?
Centimeters.
Centimeters. What unit goes to the
Centimeter.
top?
Meters.
Meter.
Okay, my 1 goes in front of centi. Centi is 10 to the minus 2. Then what do I have to do?
Cube the parentheses.
Cube.
The parentheses. Yep. So in that case, I'm going to put it in my calculator. Let me get the other calculator. I'm going to put it in my calculator that says 50, open parentheses, E -2, divided by 1, close parentheses, and then I'm going to cube it. And remember, on this calculator, to cube it, I'm going to hit this caret up button and then hit cube. Is this what you got, Johannes?
Yeah.
Okay, so what's this? This should be 1, 2,
5
3,
times.
4, 5.
5
What is-
times.
10 to the negative
10
5.
minus 5. Oh, okay.
Okay, and this is going to be meters cubed.
Okay.
All right. So if you have questions still, feel free to email me. I can meet you in office hours. Remember, I have office hours right after this class. I can answer a lot of questions during office hours. I have a tutorial video. Let me put that up too. I think I made a quick YouTube video for you guys, and I'll put that up right quickly. So in case you're having trouble, I walk through how to get these types. There's only, 4 different ways to do it. If you have 1 parentheses, if you have 2 parentheses, if you have a unit raised to the power, or if you have a unit in a fraction. So there's a video. Did I put it up here? Yep, conversion practice video. If you guys go back under chapter 2, there's a video that says conversion practice video. It's just a YouTube video that I made, and it shows you the 4 different ways that I taught you guys how to do these conversions. And it's about 5 minutes. I don't even think it's 5 minutes. Maybe it's 3 minutes. So go look at that if you're having a lot of trouble. Look at it one more time. And let's keep going. Let's talk about density. Give me like 15 minutes to talk about density, and then we can wrap up. All right. Last thing I want to talk about is density. Density is the last section of chapter 2. And this is what we're going to do our lab on Wednesday. So we're going to have our first lab on Wednesday, guys. It's the density lab. and we're gonna do it together. It's a virtual lab, but you guys need to come to class on Wednesday so that make sure we get this lab done together. It's pretty much mandatory for this density lab. So email me right away if you think you can't make it on Wednesday so we can figure something out. So density, all density is a substance's mass to volume ratio. So meaning it's just the ratio of a substance mass to its volume. That's all density is. The SI units for density, you guys remember what the SI unit is for mass?
Milligrams.
Kilogram for mass. And what about for volume? Do you remember what it is for volume?
Later.
Not liter.
Oh.
Liter is a volume. But remember length times width times height?
Oh,
M to the third.
M to the meters cubed. So this is the SI units for density. I'll say SI units. Most of the time, guys, when we talk about the units for density, we're going to use units of grams per milliliter or grams per centimeter cubed. Although this is the SI unit, in this class, we're going to use these units. So I'm going to say use these units. These units equal each other. So we know a gram equals a gram, but remember, this is a star that I'm going to say 1 milliliter is equal to 1 centimeter cubed. The only difference is when we're talking about volume, if we're talking about measuring the volume of a liquid, most of the time we're going to use liters. So just think about if you want to measure some drink that you have, or even like the drink bottles that you are given, on the label on the bottle, it usually says it's like 900 milliliters. It's measuring your liquid in milliliters or liters. And talking about the volume of a solid, we're going to say centimeters cubed, because remember a solid, you got to do the length times the width times the height. So it's like centimeter times centimeter times centimeter if we're using a ruler or some type of measuring tape. Does that make sense to you guys? They mean the same thing. One's usually for liquids, the other one's for solids. All right, so if we're talking about densities, all we really have to know is that it's the mass over volume, and then we can use that equation that says density is equal to mass over volume. Another way that I like to say that is density equals, if I can write correctly, density equals love, and then we just draw a line through it, not really, M over V. All right.
That's a good idea.
And so we just have to remember grams per milliliters or grams per centimeters cubed are the units that we want, unless the question is asking something different. So some common densities that you guys might need to know for the homework. Common densities. Some common densities is that one, water has a density of 1.0 gram per milliliter. And no matter how much water we have, whether I have a cup of water or if I have a gallon of water, the density of water does not change unless you change the temperature, but it doesn't change. So 1 gram per milliliter, the mass to volume ratio for water is always going to be 1. So density is one of those things where it doesn't matter how much of a substance you have. The density of that substance is always going to be the same. All right, let's put a star by water, because you're going to have to know the density of water. Sometimes they'll ask you a question assuming you know the density of water. And you'll say, how do I convert it? But you're going to have to use density to convert it from grams to milliliters or milliliters to grams. All right, so I'm going to put a star there. I'll say need to know. You need to know the density of water. Copper has a density of 11.4 grams per milliliter. Copper is just a metal. We use it a lot. And its density is not 11.4, sorry. Its density, scratch that out. I wrote you the density for lead. Its density is 8.96 grams per milliliter. Lead has a density of 11.4 grams per milliliter. And then gold has a density of 19.3 grams per milliliter. Now, when we talk about density, like I said, it doesn't matter how much of any of these substances that we have, its mass to volume ratio is always going to be the same. So whether I have a drop of water or a whole lake full of water, the density of water is still going to be 1 gram per milliliter. Now, the only time the density changes is if you change the temperature. So if you change the temperature of the water or any of these metals, the density will change because the mass to volume ratio will change. Now, that's when we come up with saying that, let's say, for instance, we think about water. We think about liquid water versus ice. Let's say we have a cup. This is my cup, and I have some water in it, and then I have some ice cubes. So let's say these are my ice cubes floating at the top of my water, and then water all in the cup. All right, I'm gonna mute you guys so that way I'm not sure whose computer is that. All right, so let's say I have a cup of ice water. This is ice water. What ends up happening when liquid water turns into ice, it ends up expanding. So when it expands, it has a larger volume. So that larger volume ends up making the ice less dense than the water. So that's why we see that the ice always floats on top of liquid water, because we say that less dense floats on top of more dense. So when we think about things, what ends up happening is less dense is at the top, more dense is at the bottom. So less dense floats is what I'm saying. And I'll put a star here saying ice floats on water because it is less dense than liquid water. All right, so when we talk about density, density is one of those characteristics that you can help identify unknown items, unknown substances. Meaning, let's say I am a scientist, which I am, and I go out into the field and I'm trying to figure out what this substance is. For instance, like if I'm comparing liquid water to alcohol, like rubbing alcohol, we know they're both clear substances. You know, most of us have rubbing alcohol in our bathroom cabinets. If I couldn't smell the difference, if I was just to look at them, I could measure the density of the liquid alcohol compared to the density of the water, and I could identify which one was water and which one was rubbing alcohol just based off of its density. Because like I said, the density of a substance doesn't change no matter how much of it that you have. So it's one of those things, density is one of those things that helps identify a lot of unknown substances. It comes in handy a lot for scientists. All right, let's work on some practice problems involving the equation for density. So let's say, for instance, I have a question that says a penny has a mass of 2.7 grams and a volume of 0.349 centimeters cubed. Is this penny pure copper? All right, so this is what the question is saying. It wants to know basically, do I have pure copper or not? And an easy way to figure out if I have pure copper is to calculate the density of copper. And if it matches the density of copper that I know, then it's pure copper. If it doesn't match, it's not pure copper. So remember the equation for density. Density, we could say equals love, draw a line through it, not really. And we can say, okay, it's just the mass divided by the volume. So it's just M divided by V. So what's my mass, guys?
0.7.
2.7.
2.7 grams. What's my volume?
0.349 centimeters.
0.3.
Centimeters cubed. All right. So in this case, all I simply have to do is divide the two. 2.7 divided by 0.349. Can you guys tell me how many?
7.73.
Okay, but tell me how many stick figs I should have in my answer, because we always have to.
2.
We should have 2 stick figs
2.
because I'm doing division. Division says least amount of stick figs, so that's 2 stick figs divided by 3 stick figs. We put it in our calculator. Our answer should just be 7.7.
7.7.
Yep.
7.7
centimeters cubed.
grams per centimeter cubed, which is the same thing as saying 7.7 grams per milliliter. I want to point this out, guys. These are the same thing. So in this case, if we look back at what I gave you for copper, what do you guys think? Is this pure copper or not?
No.
No.
Oh, it's not pure copper. So it doesn't match. So penny back in the day, like in the 80s and before, used to be pure copper, but after about 84, 85, I think, they started making them alloys of copper, which just means they melt other metals in with the copper. So it's not pure copper anymore. So no, this must be a penny from present day. So no, not pure copper. All right, so this is density. Density is not a hard concept to understand. It's just remembering what the equation is and remember to have our units in the right unit. Let's do one more problem to where we'd have to convert our units first. Let's see if I can do a quick problem. Let me grab one from the book right quickly. All right, a problem from the book says, okay, let's say we have this problem. Ethylene glycol, which is just antifreeze, has a density of 1.11 grams per centimeters cubed. The question says, what is the volume in liters of 3.46 kilograms of ethylene glycol? Or just better yet, the antifreeze. Yes? All right, so now in this case, you were given the density and we're asked to find the volume, and we're asked to find the volume in liters. And then it says if we start off with 3.46 kilograms. So let's not overthink this. First off, we know that we are looking for the volume. So if I wanted to rearrange the density equation to solve for volume, how would I do that, guys? I know that density equals mass over volume. How can I rearrange this equation to solve for volume?
Would you put the volume where the density goes?
Exactly.
So volume equals mass over density?
Yep. That's it. So first off, I'm using this equation now where I'm going to divide the mass by the density. So I'm given the mass, I'm given the density, but I got to make sure I have the correct units. So I need to change my kilograms to grams, and then I need to solve for my answer. So when I solve for my answer, if I change my kilograms to grams, it's going to give me my volume in centimeters cubed, and I need to make sure my volume is going to end up being in liters. So let's just take it step by step. So we understand that we have to use this equation now, mass over density, which is just this rearranged. I switch places with the density and the volume, so I'm going to plug it in, mass over density. So first, my mass, like I said, needs to be from kilograms to grams so they can cancel each other out. So how would I set this up to change it from kilograms to grams?
You do your parentheses.
Mm-hmm.
You put the kilograms on the bottom and grams on top.
Perfect. 1 kilogram equals 10 to the power of 3. We're going to do this conversion so much that you guys will just know what to do. This is 3,460. We're going to go back and forth between kilograms and grams and kilograms. So basically, I just got to move the decimal over 3 spaces. So that's my grams. So then I can say volume equals 3,460 grams divided by the density.
1.11.
1.11, but that's grams per centimeters cubed. So now my grams are going to cancel out, and I'm going to be left with centimeters cubed. So let's put this in our calculator. We're going to say 3,460 divided by 1.11. We get this. All right, so we're going to get 3,117, and I'll just wait to round into the end just so I can make sure I do my sig figs correctly. So this is centimeters cubed. Are you guys following me? Are we all on the same page?
Yes.
All right.
Yeah.
Yes.
All right, so we have centimeters cubed, but the question says, what is the volume in liters? This is my volume in centimeters cubed, so how do I change this volume to liters? And I know you guys like to overthink this. It's not as hard as it looks. So first, we should recognize that a centimeter cubed is the same thing as what?
A milliliter.
The same thing as a milliliter. So I can just go ahead and write that this is the same thing as saying milliliters. So if I want to go ahead and convert this to liters, I can just do my conversion. that says milliliters at the bottom, liters at the top. 1 milliliter equals what?
10 to the negative 3.
10 to the minus 3. So in this case, if I divide by, sorry, if I just continue this, let me just rewrite it just so it's clear. 3,117.117, open parentheses 1, sorry, open parentheses, E negative 3 divided by 1, close parentheses. This is what I get. 3.117. So 3.117 liters, but let's just make sure we have the correct number of sig figs, guys. So remember when we're talking about multiplication and division, that's pretty much all we've done here. We multiplied or divided the entire time. So the sig fig says least amount of sig figs. My original numbers, this has 3 sig figs. This has 3 sig figs. So my final answer should have how many sig figs?
3.
3. So it's going to say 1, 2, 3. I look to the right. I'm going to round this up to a 2. The answer should be 3.12
liters.
liters. And this is about as tricky as a density problem is going to get. You know, it's just, you have to pay attention to the units, make sure your units cancel out properly, make sure you're converting your units to the correct units that the question is asking, and make sure you have the correct amount of sig figs. Guys, I actually think this is a homework question.
Professor.
Mhm.
So instead of going through all this process, can't you just do 3.46 divided by 1.11 and then just go straight to 3.117, then you take it to this number of 6 figures?
Yes, you can. Yes, you can. The problem is that it works out well in this case. It does not work out well in every other case. So if you could recognize that the ratio from the ratio from, what is this, kilograms to liters is the same ratio as grams to centimeters cubed, you could get the right answer, but it's hard to recognize that sometimes. And I just think it's easier if we know how to go from, do our unit conversions. 3.46 divided by 1.11. Is that what you're saying? Can't we just do this?
Yeah.
Yes, you can, but that's if you can recognize that the ratio is the same, and you guys don't always do that. And I don't always do it either. Not even saying it like as a jab, just more or less saying it as, it's hard to see that when you're in the thick of working out a test problem or a quiz problem. But yes, the next level chemistry, if you have to take the next level chemistry, that's a good thing to be able to see and save you some time on working out problems. I didn't hear who asked that question. Who asked me that question? Just say your name.
David.
Okay, it's a good question, David. All right, guys, how you feel about density?
So
Well,
confusing a little bit.
The main thing you got to know is that the equation is mass divided by volume. If you know this equation, I think you could spend the time to work things